This video is about sequences. We're starting a new unit on sequences and series. Alright, first of all, what is a sequence? Well, a sequence is a function that is ordered using positive integers. So it's a list of numbers, and the list, we count them as first, second, third. The order they go in is first, second, third, fourth, on and on. It's a sequence of numbers, and this will make more sense as we walk through this, but it's just a list of numbers that have a certain relationship. That's what makes it a function. So for look at this, in example 1, a. Here's my sequence. A sub n is 3n minus 1. Well, n is basically its number in line. So there's the first, second, third, fourth, fifth. Okay, usually you'll find 5 terms of a sequence. Basically, it's order in line, and you take that n value and you plug it into the equation, just like you would an x into an equation. You plug it in. So I plug it in here. 3 times 1 is 3 minus 2. I'm sorry. 3 times 1 is 3 minus 1 is 2. Plug in a 2. 3 times 2 is 6 minus 1 is 5. 3 times 3 is 9 minus 1 is 8. 3 times 4 is 12 minus 1 is 11. And 3 times 5 is 15 minus 1 is 14. So the first 5 terms of my sequence would be 2, 5, 8, 11, 14. A lot of your problems today are just going to ask for what are the first 5 terms. So let's try another one here. So I'm going to do term 1, 2, 3, 4, 5. Plugging it in. So 3 plus negative 1 to the first power. Well, negative 1 to the first power is negative 1. So 3 minus 1 is 2. 2, plug it in here. Negative 1 squared is a positive 1, so 3 plus 1 is 4. 3, that's negative, so negative 1 cubed is negative 1, so we're back to 2. 4, negative 1 to the 4th power makes it positive 1, back to a 4. 5, that's an odd number, so that's going to make this whole thing negative 1 again, plus 3 would make it 2. So notice that n being in a power can change your sequence quite a bit. 2, 4, 2, 4, 2, and you can predict the rest of this, right, based on the pattern you've seen. So those are your basic sequences. They're going to be given to you in a description, kind of like an equation, a function, and you plug in values. That's basically all you're doing. All right, now alternating signs. When you have a list of numbers that alternate signs, there's a reason for that in the equation. But if the first term of your sequence is negative, then you have negative 1 to the nth power, okay? Because to the odd, 1 is odd, and odd powers are going to leave this negative 1. If the second term is negative, the first term is positive, second term is negative, then it's n plus 1, because you want these powers to be even. You want these powers to be odd, these to be even. So that's why it's first, second. So let's just walk through our list and figure out our values for our list of numbers using this expression. This is the expression of the function. So I'm just going to use this area over here as scratch. Negative 1 to the first power over 2 times 1, which is 2, minus 1. Negative 1 to the first is negative 1. 2 minus 1 is 1. So my first term is negative 1. Negative 1, second term, squared, over 2 times 2 is 4, minus 1. Negative 1 squared is positive 1. 4 minus 1 is 3. So my next term is 1/3. Negative 1 to the third power over 2 times 3, which is 6 minus 1 is 5. So I have negative 1 over 5. Negative 1 to the fourth power. 2 times 4 is 8, minus 1 is 7. It's going to be positive 1 over 7. This is the third. Get the line straight here. And then to the fifth power, 2 times 5 is 10, minus 1. So I get negative 1 over 9. Alrighty. So there's my sequence. So it goes negative 1, positive 1/3, negative 1/5, 1/7, negative 1/9. So that's what this sequence would look like. Alternating signs, and this is why. It's all about this. Oops. It's all about this guy right here that's going to create the alternating signs, and you'll see the importance of that in the next slide. Write an expression. Okay, so what you've been given so far is the expression. You had to write the list of numbers. Now we're reversing it. You're given the list of numbers. You have to write the expression. Okay? So you're going to keep that alternating signs thing in the back of your mind. Look at your list, like on example 3 here. There are no alternating signs. It's staying all positive. So I don't have to mess with that little part. The n, remember, is the order in which these numbers are going. So first, second, third, fourth. I only have 4 terms. So my first term is a 1. My second term is a 3. Third term is a 5. Fourth term is a 7. All right, so the first thing I'm going to look for is this linear, meaning is there a common difference between these two terms? So look at this. From 1 to 3, I'm adding 2, right? 3 to 5, I add 2. 5 to 7, I add 2. Okay, well that's handy. So when you notice that this is the common, there's a common thread here, then that begins your expressions. What this value is, 2, you're going to multiply it by n. So 2 times n. Well, if I just leave my expression like this, 2 times n, so 2 times 1 is 2. My first term is not 2 though. So I need to take that 2 and do something to it, add or subtract something to get it to a 1. So you and I know if you've subtracted 1, it'll be 1. So now if I try my n in there, 2 times 1 is 2, minus 1 is 1. It works for the first term. Then you check it for the second terms. 2 times 2 is 4, minus 1 is 3. Good. Third term, 2 times 3 is 6, minus 1 is 5. Fourth term, 2 times 4 is 8, minus 1 is 7. So it works for all my terms. So as long as it works, that's my expression right there. Some of them are very simple, and this is a linear one because it's a common, something's being added commonly or subtracted. It could be positive or negative here. So it's a linear expression. Okay? Let's try another one. Here we have 4 terms again. So I'm going to plug in my values. Okay, now notice there is a alternating sign here. The first term is positive, so the second term is negative. So I know that my expression has to have one of these guys in it. Okay? Well, which term is negative? The second term is negative. So I need to have this expression involved. Negative 1 to the n plus 1 power. That's in there somehow. Okay? That's taking care of the negative positive thing. Now, let's look. Is there a common difference here? Well, that's what? Minus 7. This is plus 15. This is minus 27. So there's not a common difference here. This isn't working for us. So we need to go to the next thing, okay? So this is linear, first power. Let's go to the second power. Is there a relationship between squared terms here? From the n to the a sub n, okay? Well, 1 squared is 1. 2 squared is 4. It's not quite there. Sorry. 3 squared is 9, not quite 10. 4 squared is 16, not quite 17. However, did you notice that they're all within 1? What if I took the n and squared it, the n value, and squared it, and added 1 to it? Let's just see what happens. Well, 1 squared is 1 plus 1 is 2. So it works here. 2 squared is 4 plus 1 is 5. That gives me the 5. Remember, I've taken care of the negative already down here, so I don't have to worry about the negative. But the 2 squared plus 1 is 5. 3 squared is 9 plus 1 gives me the 10. 4 squared, 16 plus 1 gives me 17. So this portion of my expression right here takes care of the alternating sign. This portion we just discovered gives us the values, the 2, the 5, the 10, 17. So n squared plus 1. Okay, these are a little more challenging. You're going to have to think about the relationship between n and a sub n and think through different possibilities, but you can do it, right? All right, for you, now I want you to try this one for class, and we'll see how you do.